Okay, I believe this is the spot where we left off yesterday, where we were just about to start the topic of symmetry, but hadn't started. That's correct, right?
I believe so.
Cool. If we're talking about graph symmetry, there's a few different types of symmetry that we can talk about. So the most obvious is just it being symmetric about the y-axis, right? So if we have this is going to be what's called an even function. So an even function has the property that f of negative x is equal to f of x. All right. So that means that if you go in the x direction or in the positive direction, or if you go in the negative direction, you get the same y value out. Another thing that another type of symmetry that we often care about is if you have like this kind of double symmetry. So you have to flip it over the y-axis and then flip it over the x-axis. So this is called an odd function. So this is f of negative x is going to be equal to negative f of x. So yeah. So does this have either of those types of symmetries? Well, let's pick a few test points, and maybe that'll kind of give you a hint. So one's an easy one, right? So if we have f of 1, it's going to be equal to 1, which is equal to negative f of negative 1, because that's negative 1 times negative 1 is 1, right? If you were to pick this point right here, so f of negative 2, that's going to be equal to negative f of 2. So that's going to be, both of them are going to equal 1/2, right? Or negative 1/2. If I had picked f of 2 as the starting point instead of the negative 1, it would have been regular 1/2. So, I mean, just looking at this graph, it basically looks like if I fold it over this axis, right, I would get the same thing. So that's also if I had flipped it over the y-axis, then the x-axis, or vice versa. But this guy right here is odd. Does that make sense to people?
Seems like it does.
Cool. So another way we can write this is this function is f of x is equal to 1 over x, which is also equal to x to the negative 1. And it's going to be tied to this exponent right here, whether or not a function is odd or even. The first one would be odd, yes. Because you flip it over the two axes and you get the same thing. What about this guy? Is this going to be odd, even, or neither? Somebody guess. Yeah. So this one's going to be neither, because if I flip it over just the x-axis, I don't get the same value. Like right here, these 2 points are not equal to each other, right? If I do 1 and negative 1, those are very clearly not equal, and I can very easily pick so 1 f of 1 versus f of negative 1. This is equal to 0, this is equal to 5. There's neither of those relations is going to hold. F of 1 is not equal to f of negative 1, and it's also not equal to f of, or negative f of negative 1.
Pardon me, Professor.
Sure.
So symmetry isn't, can it be symmetrical? It's over the X and Y axes. It's not just, you can't just pick a point, right?
Yeah. I mean, you can talk about it being symmetric about the line x equals 2, but for our class, we won't talk about that. We'll really be concerned about the axes, about the axes, about the axes. So good question. So this right here, this is a variant of the sine wave, right? So is this going to be odd, even, or neither? Well, it's a little bit harder to tell for this, but it's going to be, actually, does someone want to tell?
Is it even?
Not even. If it was even, right, we would have it would be symmetric about this line, right? But this guy does not correspond to this guy right here, right?
Okay. So it's odd.
Yeah, it's odd because so this is what it would be if we flipped it over the x-axis, or if we flipped over the y-axis, right? But then if we flip it over the x-axis again, we get down here, which is exactly what we want. And you can do that with any point. So if I look at this point, I go over here, and then I flip it over here again. So if you were to flip this over the y-axis and then flip that new image over the x-axis, you would get this original curve. So yeah, and this is going to be 1/2 sine of ax, where a stretches it or shrinks it. But what about this one? Is this odd or even or neither?
Would it be neither?
Well, not neither. Yeah, it's going to be even, right? Because if I go here, it corresponds to this. If I go here, it corresponds to this. If I go here, it corresponds to this. Like if I go over 3 to the right, that is equal to, so f of 3 is equal to f of -3. If I do f of 1, that's equal to f of -1. And it's going to also hold for all these points in the middle. Yeah, so because we have that this f of x is equal to f of -x, that means that this guy right here is even. And this is a variant of cosine. In fact, I think this is just cosine of x. What about this guy? Odd, even, neither.
Even.
Yes, very nice. This guy's even because you can flip it over the x-axis and, or sorry, the y-axis, and you get that it's, equal to itself. So, and you can pick a few test points to check that, but okay. Sorry about that. My writing pad lost connection for a second. I'm not positive, but I think that this is x to the 4th minus x squared. And remember what I said earlier about being linked to those powers, if it's going to be odd or even. What about this one?
Odd.
Yes, this is odd. If I flip this over the x-axis, and sorry, the y-axis, then flip it over the x-axis to what I get. So if you flip this over the x-axis or the y-axis, you get something that looks like this, right? And then if you flip it over this axis again, it would just end up looking like that. So it's an odd function right there. And I think that this is going to be something like x cubed minus x. What about this one right here? Any intuitions?
Odd.
Yeah, this is going to be an odd function. It's a wonky odd function, but it is an odd function. Again, because you flip it over the y-axis, then you flip it over the x-axis, and then it overlaps itself.
Pardon me, Professor.
Sure.
Just because this is so crazy, are we only worried about symmetry for things that are actually functions, or just like, will we only be asked symmetry about functions, or will it be like a circle or something like that?
Well, it will only be functions. If I'm going to ask you something, it's going to be functions, because like the actual definition is not this pictorial definition. It's the f of x is equal to f of negative x for even, and for odd it's f of x is equal to negative f of negative x. So that's not actually defined if I just give you a circle, right? Because that's not a function.
Okay.
Something like this is a very wonky function, and it's often helpful to just kind of get a pictorial idea of what's happening before you dive into the formal definition and kind of start using that. But this can be also easier to check if it's odd or even. So if I give you either, I can give you a picture and ask you if it's odd, even, or neither. Or I can just give you a, like, you know, f of x is equal to x to the fourth plus 3x squared plus 2. Is this, or that's not 2, plus 2. Is this odd, even, or neither? Turns out it's even. And you can check that using these definitions. But, so those, that's kind of how you go through and check it. If you have a picture, a graph of the function. If you don't have the graph of a function either, you can graph the function and use that to figure out what's going on, or you can use these definitions to check what's going on. And there's going to be an important little trick that I already kind of alluded to. So if we have this one, well, one thing I can do is I can literally plug in f of negative x and see what it'll give me. So if I do f of negative x, that's going to be equal to negative x squared plus 2, which is equal to x squared plus 2, and that's equal to f of x, right? So this tells me that in general this has to be even. I can do the same thing right here. I can do f of negative x. It's going to be equal to negative x cubed minus 5. That's going to be equal to, it's going to be equal to negative x cubed minus 5, which is not equal to x cubed minus 5, right? Got this, that negative there is very important. So this is not that, and it's also not equal to the negative of this. It's not equal to negative x cubed plus 5, because we got that negative right there. So this right here is not either. Does that make sense to people?
I think it does.
Cool. So f of negative x here, I'm actually just going to change colors so that's clear kind of what I'm talking about when we run into things. That's going to be equal to negative x squared minus 2. Oh, sorry, divide by negative x cubed plus 2 times negative x. So this right here is going to be equal to x squared minus 2 divided by negative x cubed minus 2x is equal to negative x squared minus 2 divided by, there's our x squared. Yeah, negative x squared minus 2 times x cubed plus 2x, right? So I just pulled the negative out of the bottom and just put it up top there, right? So this right here is equal to negative f of x. So what does that tell me this is?
Would this be odd?
Exactly, right? So odd, because we have negative f of negative x is equal to negative f of x. Even if I wrote it kind of ugly there, sorry about that. And then finally, if we do f of negative x, that's equal to the cube root of negative x, and that is equal to negative cube root of x. So what is this?
Would it be odd?
Exactly. Cool. So before we wrap this one up, this can be written as x squared plus 2 times x to the 0. X squared is going to be an even function. You can check that pretty easily. X to the 0 is going to be an even function. It's just a constant function. Constant functions are even. X to the 4th is also even. You can check that. X to the 6th is even. And then if you take any two even functions and you add them together, you still have an even function. So that's why even plus even is even. And then if we have x, this is equal to x to the 1, right? This is odd. So this is a very easy one to check. F of negative x is equal to negative x is equal to negative f of x, right? X cubed is also odd. X to the 5th is also odd. And if you add together two odd functions, you get another odd function. So if we have x, we have x to the 5th plus 7x, that's odd. So if you multiply it by a constant, that's not going to change it. But if you have odd plus even, that's neither. So that's what we see here. So this right here is odd. This right here is even. And together it gives us a neither. Does that make sense? The only other thing to
It does.
Cool. The only other thing to keep note of is odd times odd is even. Even times even is even. And odd times even is odd. And that times can also be divided by. So this right here, this is odd, and so is, this is also going to be odd. If you do like 1 divided by an odd function, that'll be an odd function. And then this right here is even. So we had even divide by odd, and that gave us odd. Does that make sense to people?
Okay, I think so.
Cool, good. But like this right here, like this is even why we call them odd and even, because they correspond to odd and even exponents and functions. So the rest is just homework.
Pardon me.
Sure.
Just to make sure, an odd divided by odd is an even, right?
Yes, odd divide by odd is even.
Thank you.
No problem. And if you ever kind of get a bit hesitant with these rules, you can just plug in a test case. So you can do like x to the 5th divided by x cubed. That's going to be x squared. So this is odd over odd, and it gives you even. Cool.
Yes, thank you.
No problem. So you can try your hands at the homework. If you're struggling with any of the homeworks, including the stuff that was due today, you should just go to the MRC. Kind of unrelated thing that I forgot to mention last week, before I transition to talking about chapter 4, there is on the Blackboard page a link to the YouTube channel where I'm going to post the old lectures. So if you need to go back and check anything, you can go here. And, you know, watch any of the old videos. If you want to get notified whenever I post them, you can toss it a subscription and, you know, help me on the way to YouTube monetization. I'm only 978 subscribers away. So and also about 4,000 viewing hours away. So if you want to binge watch a lot.
Make sure you smash that like button.
Yeah. Yeah. Thank you. Make me sense on the hour for your watch time. Cool. So now we're going to look at combinations of functions. So there's a few different ways that we combine functions. We actually were just talking about, you know, multiplying and dividing functions. So multiplying and dividing odd and even functions to see how that affects your odd or evenness. We also just talked about adding or subtracting. So remember, we said if you add or subtract odd and odd, you'll still get odd. If you add or subtract even and even, you'll still get even. But if you add or subtract odd and even, you'll get neither. So, and then another one that's very important is the composition of functions. So that's basically just plugging one function into another function, and then seeing what we get out. There's also some other related things. So we can talk about if a function's one-to-one, which basically means that every x value will correspond to a unique y value. And if you have that, then you can find an inverse function. So basically that just allows you to reverse it. So yeah, we'll see a bit more of that in a minute. Yeah, this So first, let's talk about, adding and subtracting functions and, multiplying, dividing them. So given this, what is f plus g of x, given these guys? Well, it's literally just going to be this plus this. So we have x squared, which you're going to clean this up a little bit. X squared minus 2x plus 5. And then we have plus 4x plus 2. So this is equal to x squared plus 2x plus 7. F of x, or f minus g of x, is going to be equal to f of x minus g of x. So that's going to be equal to x squared minus 2x plus 5 minus 4x plus 2. So this is going to be equal to x squared. Distribute that minus, so we get minus 6x, and that plus 2 becomes minus 2, and we get plus 3. Right? F times g of x is equal to f of x times g of x. So this guy will have to FOIL out a little bit. X squared minus 2x. Yeah. Nubong.
So for this portion right now, so I know there's like an something called f of x. F of g, or like g of f. So what you're doing right now is that not what it is, or?
No, so multiplication of functions is different. So
Right.
we'll cover that with the f composed of g, or f of g of x, in a minute, and that has this notation.
Okay.
But that's basically plugging in f g of x into f of x. So that gives us f of 4x plus 2, and that's going to be equal to 4x plus 2 squared minus 2 times 4x plus 2 plus 5, and then do that out and simplify. But
Okay.
that composition, that's a different thing. But good question. So this right here we distribute. So we get 4x cubed minus 8x squared minus 8x squared again, minus 4x plus 20x plus 10. Squared minus plus 16x plus 10. So that's what we get when we distribute out like that, f times g of x. And then if we do f divided by g of x, it's going to be f of x divided by g of x. And that's just going to be plus 2. That's just going to be that guy, which you can't really simplify anymore. So does this make sense to everybody?
It does.
Cool. And somebody tell me what they are for B.
You say that part again. What for B?
Solve these guys for B. Tell me what the answers are.
For the first one, x plus 1 plus the root of x minus 4.
Perfect.
Or the second one, would it be x plus 1 minus x minus 4?
Yes, exactly.
For the third one, would it be x plus 1 times x minus 4?
Yep. And this one, you could distribute it, but it doesn't actually give you anything much nicer if you do this. So I would probably leave it like this, but if you wanted to distribute it, that's fine.
Okay, you won't be wrong if you just leave it like that.
Yeah, this, especially for this one, like that, you don't really get any benefit to doing it out.
Okay. And for the last one, would it be x plus 1 over x minus 4? And can you just leave it like that?
Almost. I think you probably had it right, but you didn't.
Oh, sorry, square root x minus 4.
Exactly. But yeah, that's perfect. You can't really simplify this one at all. So, and it'll be the same basic procedure for C. I'll let you guys do that by yourselves and jump onto the function composition here, which we already briefly saw an example of. But, so if you want to do the function composition here, we would have f of g of, so f composed of g of x. We basically read it from the inside out. So this is f of g of x. That's going to be f of 2x plus 1 is equal to, everywhere where we see an x, we replace it with 2x plus 1, remember? So that's going to be equal to 2x plus 1 squared plus 2x plus 1. So if we square this out, FOIL 2x plus 1 times 2x plus 1, it's going to be squared plus that, is going to be plus 4x, and then plus 1, and we get plus 2x plus 1. So that's what we get for f composed of g, or g of, or f of g of x. And then if we want to do the opposite direction, if we wanted to do g of f of x, it would be g composed of f. It would be this to so everywhere where I see an x in this, I replace it with x squared plus x. So we get 2 times x squared plus x plus 1. It's equal to 2x squared plus 2x plus 1. Make sense?
It does.
Okay, cool. Yeah, let's do them for this. Let's do f of g of x. That's f of g. So everywhere I see an x in here, I replace it with x squared. This is equal to square root of 3x squared minus 1. G of f would be equal to g composed of f is going to be equal to g of f of x is going to be equal to g of the cube root 3x minus 1. So that'll be equal to or sorry, the square root of 3x minus 1. 3x minus 1 squared. So it's going to be equal to 3x minus 1. Cool.
Cool.
And then this guy, this would be we divide by x minus 3. So we do this, well, everywhere we see an x, we're going to replace it with this. And I'm actually just going to rewrite this as x to the negative 1. They're the same thing, but they're equivalent. That gives us 3x plus 2 divided by x minus 3 to the negative 1. And that's just going to have us flip this over. So it's going to make this into x minus 3 divided by 3x plus 2. Cool. We could go through and do it again for the other one, but it's just going to be a bit of an ugly mess. It won't actually be inlining for us to do g of f for this one. But another useful thing is, hey, we don't just have to do g of f of x, we can actually evaluate x at a point. So to give a quick example of that, if we do f of g of negative 1, first off, let's find out what f of g of x is, right? So let's do f of g of x. We can do that's f of 2 minus x squared. So that's going to be equal to 4 times 2 minus x squared plus 3 equal to 8 minus 4x squared plus 3. So that's equal to 11 minus 4x squared. And now if I want to do f of g of negative 1, I can just plug that in. So I would do 11 minus 4 times negative 1 squared. It's going to be equal to 7. Because this guy just becomes 1. Alternatively, I could have done f of g of negative 1 is equal to f of g of negative 1. What's g of negative 1? I plug that in, I see g of negative 1 is 1. So this is equal to f of 1. And then I get that's equal to 4 times 1 plus 3 is equal to 7. And they give me the same answer both ways, right? So you can do it either of these ways. But if you're going to be plugging in a bunch of values, it'll probably be easier for you to figure out what f of g of x is at first, versus if you just need to plug in one value, it might be easier for you to just plug in from the get-go. We'll do all of them both ways though. So if I want to plug in 0, well then I could just plug in f of g of 0, and that's going to be 11 minus 4 times 0 is equal to 11. Or I could do so g of 0 is equal to 2. F of 2 is equal to 2 times 4. I guess 4 times 2, but whatever. 4 times 2 plus 3 is equal to 11. And then I could also do, for 1, if I did f of g of 1, that would be 11 minus 4 times 1 squared is equal to 11 minus 4 is equal to 7. And that's also equal to g of 1 is equal to 2 minus 1 squared is equal to 1. And then f of 1 is equal to 4 times 1 plus 3 is equal to 7. So if you either solve it out first in general for x, or if you just plug it in straight from the get-go, you should get the same thing for both of these. Does that make sense?
It does.
Cool. Okay, so I think I'm going to call it here and just let you guys out a few minutes early. I'll stick around if anyone has any questions that they want to ask.
Thank you.
Pardon,
A good one.
pardon me.
Sure.
You said the